In Chapter 1, Section 6, we're going to talk about relations. So by the end of this lesson, you should be able to represent relations, and we're going to do this in a few different ways. You're going to do it as a table, a graph, and a mapping diagram. And then you should also be able to interpret graphs of relations. So let's talk about the graphs. Hopefully this should be a review, but we have a coordinate system with a coordinate plane, and it intersects two number lines. We have the horizontal and the vertical axis. So this guy is your x-axis, goes horizontally. This guy is your y-axis, it goes vertically. And on this axis, you always have an origin, that's a 0, 0. The coordinate plane that we label stuff on has ordered pairs. So they're called ordered pairs because the order matters. X always comes first, and then Y, and then we put parentheses around them. So 2, 3 means I go over 2 on the X and up 3 on the Y. Everything here is positive, positive, both X's and Y's. Over here, your X's are negative, but your Y's are positive. Down here, your X's are negative and your Y's are negative. And over here, all your X's are positive and your Y's are negative. So a point is always represented by ordered pairs. Remember, we call these coordinates also, and they're always in this form, x comma y. X value is called the x coordinate, the y value is called the y coordinate, and then this is the part that we need for this lesson. A set of ordered pairs is always called a relation, and it's called that because x and y have a relationship. So our relations can be depicted in several different ways. We're going to wait on equations until later in this class, so we're going to do graphs, tables, and mappings today. So a mapping illustrates how each element of the domain is paired with an element of the range. So hopefully you've heard those words before. The set of the first numbers in the ordered pair is your domain. So whenever you think the word domain, I want you to think x values, input, an independent variable. And it's always the first thing. It's the x in the ordered pair. Your range is the second set of numbers. Your range is always your y values. It's your output. It's your dependent variable. And it's always the y part of your coordinate, that guy there. So this mapping here shows us that these points, negative 2, 4, the negative 2 is in the domain, and it maps over to 4. And then negative 1 also maps to 4. So it kind of just gives us an idea of going from one to the other. So here are the ways you're going to see things: as an ordered pair, as a table, a graph, or a mapping. So these three ordered pairs can be represented in these three ways. And like the next problem we're going to do, I'm going to give you ordered pairs and you're going to have to do all three. So we have 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. The table is always the easiest, and in a table we always do the x values first and then our y values. We basically just copy down the points but put them across from each other in a table. So the first one's at 2, 5, the next one's at negative 2, 3, and we have 5, negative 2, and then negative 1, negative 2. Now with this, sometimes it makes sense to order them, so we usually order by the x values, smallest to largest, but you don't have to. As a graph, all we got to do is plot these points. So 2, 5 is a point, negative 2, 3 is a point, 5, negative 2, so remember that means over 5 on the x, down 2 on the y. And then the last one, negative 1, negative 2, means I'm going to go backwards 1 and down 2. So that represents this set of numbers on a graph. And now the last one's a mapping. Now the thing with mapping is it always needs to be in order. So you need to order your domain values and your range values, and if not, this is totally wrong. The other thing about a mapping is you can't repeat numbers. So if you look, we have -2 twice here as the range. We are only going to write it once. So let's just look at our x values first. So my x values are 2, -2, 5, -1. Now these need to be written in order from smallest to biggest. So we're going to have -2 first, then -1, 2, and then 5. And we sometimes draw like an oval around this or a square, it doesn't really matter. And now our y values are 5, 3, -2, and -2. So again, it needs to be in order, and we can't list things twice. So we only need -2 on here once. Our next biggest number is 3, and then our last one is 5. And now this is the mapping part. We're going to draw arrows to the things that connect. So we go back up here and look at our points. 2 needs to go to 5. So 2 goes to 5. The next one says -2 needs to go to 3. So that's mapped onto there. The next one says 5 needs to go to -2. And then -1 needs to go to -2. Okay, so you're just showing where they line up. And this will all three of these methods will come in handy tomorrow when we talk about functions. So determine the domain and range. Our domain is all of our input values. These need to be in order and we can't repeat. So we just did that for our mapping diagram. Our domain is -2, -1, 2, and 5. Now these squiggly brackets here are just listing a set of numbers. We don't want to put parentheses around them because we're not grouping them as a point. And then our range is all the outputs. Again, needs to be in order and can't repeat. So we just did that on the mapping. We got -2, 3, and 5. Alright, so we used these words earlier, but independent and dependent variable is something you're hopefully also learning in science class right now too. But in a relation, the value of the variable that determines the output is called the independent variable. Remember, this is your x value as well. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. Remember, this is your y value. Domain is independent, range is dependent. So you'll get a story like this where you have to identify what's being changed and what's changing as a result for each relation. So whenever I teach a science class, I always talk about the independent variable being something that I am changing as the experimenter. And then as a result of that, something else has to change as well. So this first one says the air pressure inside a tire increases with the temperature. So when we think about what I'm going to change as the experimenter and then what happens as a result is I am going to change, I'm going to change the temperature. This is my independent variable. And then because the temperature changes, the air pressure changes as a result. That's your dependent variable. So same thing with this next one. It says the amount of rain decreases, so does the water level of the river. So what's changing first? It's supposed to be the amount of rain changes first. That's your independent variable. And then as a result, and it even says so does the, that means as a result of the water level of the river changes. That's your dependent variable. So these examples are good ones because it shows you that it's not always the first thing that's the independent and it's not always the second thing that's the dependent. It can change around. You just got to pay attention to it. Alright, last thing, we got graphs of a relation. So when we look at these graphs, you need to pay attention to several things. You need to pay attention to the heading up here. That tells you what's going on. This down here is always your independent variable, so what's changing as a result of the experimenter. And then this is always your dependent variable, so whatever we're talking about. So this graph represents the distance that Francesca has ridden on her bike. Describe what happens in the graph. So this one is done for us. It says as time increases, so as time moves on, the distance increases until the graph becomes a horizontal line. So time is increasing, but distance remains the same. At this section, Francesca is stopped. then she continues to ride her bike. So right here, we know she had to take a stop somewhere because the distance from her house or wherever hasn't changed. Now we could even talk about the slope of these two lines right here. If you look here versus here, this one's a little steeper. That means that she was traveling faster. And this is a little slower. So let's try some on our own. So describe what's happening in each graph. We're driving to school. So think about what would happen if you were actually driving to school. You'd go a little bit, you'd probably stop at a stop sign or a stoplight or something, and then you'd continue on. So when I look at this graph, the first thing I notice is there's two flat parts right here. And because this is distance versus time again, these two flat parts means that I was stopped at a light something. Now these parts here where the distance is growing means that I was traveling, but like this, I'm going pretty fast. Where this is pretty slow, but I'm still moving. And then this is somewhere in between fast and slow. So this one, change in income, we have our time that's going on, that's our independent variable, and as a result, our income is steadily going up. And there's this hump here where it goes up a lot, and then it comes back down. So we can say increase in pay, where these two things is kind of a steady increase. So you should be able to do these three things. The first one, you need to express the relation as a table, a graph, and a mapping, and then tell me the domain and range. And then in this one, you need to tell me what's happening in the story right here. We'll practice this all in class, but make sure you write down any questions you have, and we can go over them together at the beginning. Enjoy your night.